Hello everyone, and welcome to the Chapter 13 video for Ground School. This chapter is all about GPS approaches. This is probably a time that many of you have been waiting for. So let's go ahead and get started. So Rod starts out talking about the different kinds of approaches and the different phases of approaches. And he talks about phase 2, which is what they call the overlay phase, where you have an approach that's an existing approach, and they said, hey, guess what? We could also use GPS for navigation for this approach. Now, I want you guys to know I had to really search to find one of those that's still in existence today in the entire state of Pennsylvania. And I did eventually come up with this guy here down at DEC. So this is the VOR DME or GPS Alpha. So whenever you see something or GPS, then that would indicate that you have a hybrid approach or what we call an overlay approach. By the way, I was also looking, I actually got out my old physical approach plates. So I have them here in a binder for Pennsylvania, West Virginia, and then I have some nearby states as well. But I, got this out and thought, I wonder if I can find any NDB approaches in Pennsylvania as well. And the answer to that was I only found them at an Air Force base. So I didn't see any civilian airports in the state. Now, I could have missed one, but from the searching that I've done, I haven't been able to find anyone still using NDBs in Pennsylvania. Okay, so on to this approach. It's a dash alpha approach. That means it has circling only minimums. We've talked about what that means before. If we brief this approach plate, we'll see that it's Myerstown, Pennsylvania. It's based on the VOR-TAC on 114.6, TAC and channel 93. Approach course is 145. And runway landing distance, NA, same as touchdown zone elevation because it's an approach to an airport, not a runway. The airport has an elevation of 523. You notice there's a T. That means that departure procedures or non-standard takeoff minimums exist. The A says NA. You cannot file this thing as an alternate. And it says use Harrisburg International PA altimeter setting if not received. Procedure not authorized. Circling runway 1 not authorized at night. So there's a few restrictions here. Missed approach procedure tells you what that is. Then you have your frequencies and all of that. All right. So I didn't really want to get that much into this, just to show you that this is an example of an overlay approach where you can use some sort of navigation, in this case VOR DME, or you can use a GPS. Rod talks about some other kinds of approaches that you might see, and he begins with the I approach. So what's an I approach? Basically, you've got this straight line into a runway. So this is the approach to runway 4 at Wilkes-Barre. Again, if I were to brief this approach, it's Wilkes-Barre, Scranton, Pennsylvania. And notice here it says WAS, and here's the WAS channel. So remember, WAS is the Wide Area Augmentation System, and that provides you a more precise GPS location, and it also can allow you to have vertical navigation. So some of the GPS approaches will allow you to have a glide slope, essentially, and you need to have WAS for the most part for that to happen. We'll talk a little bit more about that later. So here we have our standard bits of information. Again, at this point, I don't really want to brief this fully. I just want to show you what's new. So this is called an eye approach because we have all of our waypoints here arranged in a line. And this one, like many of the eye approaches, will have a holding pattern reversal here at the top. You'll notice that Roxy is both an intermediate fix and an initial approach fix. So you pretty much would fly to Roxy and then do some sort of reversal and then fly inbound, assuming that you weren't being vectored in for the straight in approach. Now, instead of having the little circle with the MSAs that we're used to, this is a little different, and this is something you'll see very commonly with some GPS approaches where I have these two half circles in this case. And if I'm going out to 10 miles, I have to be above 4,000 feet in this area. And if I'm going out to 30 miles from Roxy, I have to be at 4,200 feet. Whereas on this side, it's 4,000 up to 10 miles, and then 4,300 up to 30 miles in this direction. And I'm going to take a cue from Rod. I'm not going to start drilling down into the minimums just yet. I just want to start with the plan view and what's different. So another approach, this one's into Bloom. We'll come back to that. And somewhere I have right here, this is into Bradford County. This is what they call a T approach. We have a waypoint over here, another one on the other side, and those are pretty much perpendicular to a path inbound to my intermediate fix. And then from there, I have my final approach fix. Now this one, you might say it's not a good T because there's this slight change of direction. Well, okay, but the starting port is a T. So most people would still call this a T approach. And once again, we have our familiar MSA circle here. Goes out 25 miles and tells me I have to be at 3,900 feet. Then we have a modified T, kind of like this approach into Lancaster, runway 8, where I've got an approach fix here and then one down here to the southwest. And it's more like a Y, but this would be called a modified T approach. Once again, MSA circle, as you're used to seeing. So yeah, there's just a couple of different kinds of approaches. Now this one, of course, is going to show you a modified T, but this also will give you different altitudes. So here I've got Haro out here, and here are the altitudes for approaching this way, and then I have my straight in altitudes and my approach from this side. So they'll typically refer to this as the right base area and the left base area and the straight in area. That's how you might hear it referred to by controllers and such. Okay, so that's the plan view. Now in the book, Rod talks about things like clearances and what are your clearances as you come in for the approach. You can read all of that. One thing that I do want to point out that I think it's important for you to know is the difference between WAS and non-WAS enabled instrumentation. So if you have a GPS that is not WAS enabled, the sensitivity is actually different on the scales. So if you look at figure 3A in your book, he talks about that. And when you're en route, 1 dot is a nautical mile. And then when you get started on your approach, Once you get to that intermediate segment, now 1 dot is equal to 0.2 nautical miles. And then when you get to the final segment, 1 dot is 365 feet. And how does that differ from WAS? Well, for WAS, when you're en route, 1 dot is 0.4 nautical miles. So the en route sensitivity is a lot better. The intermediate sensitivity is the same. 1 dot's 0.2 nautical miles. And then when you get onto that final approach segment, it's about the same sensitivity as a localizer. So it's slightly different. By the way, if you ever fly glass cockpit planes, the HSI, instead of having 5 dots, they'll do crazy things like say, hey, let's just put in 2 or 3. And then you're like, well, how much is the dot worth now? Yeah, I don't know why they decided to do that, but they did. So basically, that would change all these things. But I don't think most of you are flying glass right now, and that's something, it's a minor thing that you could learn to adjust later. He also talks a little bit about RNPs, required navigation performance. There will be some approaches where you'll see RNP. And if you look in the briefing section, it will tell you what kind of RNP you need. If it says 0.3, that's what a WAS-enabled GPS will give you. So that means that you're within 0.3 nautical miles of the center line 95% of the time if your CDI is centered. That's what RNP of 0.3 means. Okay, so we talked a little bit about the different plan views. And then we said, some of the newer ones are going to have this terminal area arrival format, the TAA. And that format is where you have these fixes and the altitudes, kind of like what we have here into Williamsport. And that's sort of like the latest and greatest format. And that's something that you might see a lot of things moving toward. Okay. So now let's start talking about these approach minimums. So I'm going to go back here to Bloomsburg. I'll go ahead and expand this a little bit. So the GPS approach into Bloomsburg is into Bloomsburg, Pennsylvania. Approach course is 073. Runway length, not applicable. Same thing, touchdown zone elevation. Airport elevations, 481. And there's a T, and the A says NA, not authorized as a use for an alternate. Helicopter visibility reduction below 1 statute mile, NA. DME, RNP, 0.3, NA. Procedure not authorized at night. Use Williamsport altimeter setting. So just like the other procedure that we looked at before, it's not authorized at nighttime. So can you come in IFR at nighttime at Bloom? Well, you can visually. That's pretty much the answer to that. So this says DME, RNP not authorized. And you might think, what is that? If you look in the book, Rod talks a little bit about DME, and how that works. In general, RNAV works by using VORs and DME in combination. And so how would I want to use that? I can't use a traditional RNAV system if it uses DME. If it's just a RNAV system that uses VOR and a single DME, I'm okay. So that's just a little minor point. Probably won't affect anybody because you probably don't have that equipment. If you don't know what DME is, you probably don't have it. Okay. Missed approach, climbing left turn to 4,000 direct MIP, Vortac and hold. Continue climb and hold to 4,000. Here's our plan view. Here I have an initial approach fix of the Selinsgrove VOR. And notice it says no PT, 3200 no PT, a heading 070. So what that means is that I will need to come straight in and I don't turn in this hold. I also have Punley as an alternative initial approach fix. And so is JMIP. So I might come straight into JMIP from some direction, don't care what direction, in which case I'm probably going to do this reversal. Or if I go to Punley or to the Selinsgrove VOR, I can go straight in and then turn in the case of Punley, or just go straight in the case of Selinsgrove. Now, here's something that's pretty cool about GPS approaches. They have turn anticipation. So your GPS is smart enough to say, hey, you're approaching this hard right turn or hard left turn here. Right, you're going to turn 90 degrees. It'll tell you when to start that turn. Otherwise, you would blow right past this course. So that's kind of a cool thing about GPS. You don't have to do all these procedure turns. You don't have to do holding pattern entry reversals all the time, at least. And that's another nicety of the GPS world. Okay. All of these waypoints here have this symbol. Those are flyby waypoints. What does that mean? You just have to fly close to them. You don't have to fly over them. So, for example, if I'm coming from Punley, I'm going to turn left. I'm never actually going to fly over JMIP in that case, but that's okay. Now, sometimes you'll see the symbol with a circle around it. That means it's a fly over. And you might see that for, say, missed approach point, such as this one right here. That's a fly over waypoint. In other words, if you go missed, you're supposed to fly to that point before you do anything else. Don't just start turning. You might run into something. That's what that means. All right, minimum sector altitude, 4,000's up here. Of course, we see the river. We see some obstacles and such around here. If we look at the Aerodrome Sketch, it's pretty boring. Here we have our approach path. Here's the runway. Of course, I just realized that they have the beacon in the wrong place, because the beacon's really over here now. Maybe somebody should update that. And, down here in our minimum section, here's our profile view. We started at 3,200 till we crossed JMIP. Then we get down to 2,500 or above. Cross FOLIV. That is our final approach fix, as indicated by the Maltese cross. Slight change of course to 073. We go to Ganry. If we don't see our airport by then, we have to go missed. Missed approach procedure is climbing left turn to 4,000 MIP and hold. And you'll notice if you're Cat C or D, you're not even authorized to do this approach. And during the daytime in Cat A or B, you can go to 1540 or 1560 with either mile and a quarter viz or a mile and a half viz. So that is a very basic GPS approach going into Bloom. Now, if you're lucky, you'll find a slightly better approach. So here's an approach into Wilkes-Barre. And this one has circling minimums, and it also has, here it says LNAV MDA. What does that mean? Lateral navigation. So if I have a non-WAS GPS, this is my minimum descent altitude, 1680. So it's a little bit better than if I was just circling. If we have a sneak peek here at the plan view, you'll see it's also kind of an I approach, has a holding pattern reversal here. Aerodrome Sketch says, hey, I'm coming straight in on runway 4. What kind of lighting do I have? And I have a PAPI as well. That's what it's telling me. There's the tower. Pretty basic stuff. All right, so back to this. If I have no WAS, this is a non-precision approach. It can be a precision approach if I have Baro VNav. And you're like, well, what is that? Barometric pressure-based vertical navigation. This is one of those things where if you don't know what it is, you probably don't have that equipment. And often you will see that there are limitations if you're using LNAV VNav based on barometric VNav systems. So notice it says for uncompensated baro VNav systems, LNAV VNav not authorized below minus 17 Celsius or above 54 Celsius, because those systems aren't good enough because of being based on pressure. So that's just a little FYI. Okay, and then there's the thing that you really want, LPV, Localizer Performance Vertical Nav. And here we have a decision altitude of 1162. So again, real quickly, if I'm flying this approach, if I don't have WAS and I don't have Baro VNav, this is my minimum altitude, 1680 in this case. If I do have Baro VNav, then I can go down to 1618. If I have WAS and the right conditions are met, I can go down to 1162 and 2400 foot RVR. Okay. So let's back up just a little bit and talk about these in a little bit more detail. When I'm approaching an airport with a WAS-enabled GPS, certain conditions need to be met for me to be able to fly LPV, which is the best. In order to be able to get that level of precision, I have to fly a decent approach. So when I come in over my final approach fix here, if I'm like full scale deflection here, it's not going to arm the approach. And if I'm too far off or the conditions aren't right, it will also not give me a LPV approach. So how do I know this is happening? You know, if I'm planning on LPV, but I didn't quite get it. Well, the way that you know that that's happening is that your GPS unit will display the best precision that you can get. So if you look in your book, you will see it's figure 17, where he talks about the different kinds of precisions that you can get. So LPV is what you want. There's LNAV, or I'm sorry, L/VNav, which is basically LNav, VNav. And then there's LNav plus V. Now, LNav plus V, the glide slope that's provided is just advisory. It's not a real glide slope, if you will. And then if it's really bad, it'll just say LNav. So that's the way that the GPS will tell you what you're going to get. So if I look at Williamsport, once again, this is a modified T. And this one is a little bit different. You'll notice that it says LPV DA and LPV DA with a hash mark. So what's the difference? Well, you need to look and find the difference, basically. But for the most part, if you're flying in your Cessna, you're probably going to be dealing with this at best, and not with the hash mark. Rod, some things that Rod does mention, by the way, if you have a good GPS approach into a nice, big, busy airport, you're probably going to get down to kind of ILS altitudes. You know, here we have 250 feet. That's pretty close to 200. However, just because you have LPV doesn't mean that you will automatically be able to get down to those lowest altitudes. You need to have an approach lighting system. Right? You have to have a Mauser system, et cetera, et cetera. So here they have a Mauser. That's what it tells me on the approach plate. There's another approach into Wilkes-Barre. This one, again, does have LPV. And this one will take you all the way down to 200 feet, which is the same as a ILS. Not all ILSs will even bring you down that far. Just something to keep in mind. Some ILSs are non-standard, or there's something weird going on in that area, so they won't let you get down that far. Same thing here, Lancaster. Gets you down to 200 feet. Half-mile visibility. That's pretty good. Here at Bradford County, there is no glide slope. It's just like Bloom. It's going to get you down to a certain level, and that's it. 1,800 feet, still over 1,000 feet in the air. It's not awesome, but it's better than nothing. All right, so that is pretty much the basics of GPS approaches. So that is it for chapter 13.